First definition, inconsistent. Inconsistent is two lines that do not cross. Inconsistent is basically parallel lines. Consistent is two lines that cross. So consistence would be any two lines that are not parallel. If two lines are consistent, they're either independent or dependent. Independent lines are two different lines or equations, and dependent lines is the same line or same equation. Title of the first section is Define the Following. We'll use the definitions that we just did to define two lines that are on a graph. The first graph is two lines that go side by side, or they're parallel lines. The definition of these lines, since they're parallel, they're two lines that do not cross, the definition would be inconsistent. Inconsistent, again, are two parallel lines. Second question and second graph are two lines that cross. Two lines that cross are consistent. If you have two lines that cross that are consistent, consistent lines are either independent or dependent. Looking at the graph, we have two separate lines. If we have two separate lines or two different lines, it would be consistent and independent. And last question for the section. We have one line and another line on top of that same line. These two lines do cross. They cross at every single point that they have in common. So since they do cross each other, these two lines are consistent. And again, if you have consistent lines, consistent is either independent or dependent. In this case, we have one line on top of the same line, which means it's the same line or same equation, so it would be dependent. So the final answer, consistent and dependent. Title of the next section is Graph and Define the following. In this section, we'll graph two lines and define them using the definitions. First question, first equation is y equals 2x minus 4. And second equation, y equals negative 3x plus 1. And again, we'll graph each of these lines. After we graph, we'll define using the definitions. Both of these lines are in mx plus b form, or slope-intercept form. The first line, 2x minus 4, m is equal to 2, or 2 over 1, and b, the y-intercept, is negative 4. Second equation, m, the slope, is negative 3, or negative 3 over 1, and b is positive 1. Once we have the slope and the y-intercept, we can graph each of these. The first line, the y-intercept, starts at negative 4. And the slope is 2 over 1, so we'll go up 2 and over 1. Second equation, the y-intercept is positive 1. And the slope is negative 3 over 1, so we'll go down 3 spots and over one spot. To define these lines cross at a single point, which means it's consistent. Consistent means the lines do cross, and the lines are two separate lines or two different equations, which means they're independent. And that would be the answer to the question. Second question and last question for the section. First equation is 9x minus 6y equals 24. And second equation, 6x minus 4y equals 16. These lines are in standard form, where we have x and y on the same side. If we wanted to, we could graph these using intercepts. Intercepts is where we'll plug zeros in for x and y. If we plug a 0 in for the first equation for x, we can solve for y and find the y-intercept. 9 times 0 would cancel. Negative 6y equals 24. We divide by negative 6, and y equals negative 4. Solving the same equation, but this time putting a 0 for the y value, we can find the x-intercept. Negative 6 times 0 would cancel. 9x equals 24. We can divide by 9. And x equals... 9 doesn't go into 24, but we can reduce. And it reduces to 8 over 3. So the two intercepts, y equals negative 4, x equals 8 over 3. We can use those in graph just a minute for the first line. Solving the second equation, 6x minus 4y equals 16. Again, we can plug a 0 in for x. Six times 0 would cancel. Dividing by negative 4. And y equals negative 4. Solving the same equation again, but a 0 for y this time. Negative 4 times 0 would cancel. Dividing by 6. And x equals, reducing 16 over 6 would be 8 over 3. Graphing these two lines. The first line has a y-intercept at negative 4. And also has a x-intercept at 8 over 3. 8 over 3 is the same as 2 and 2/3. So in between 2 and 3. Graphing the second line, you'll notice the intercepts are the same points. Y equals negative 4 again, and x equals 8 over 3. So we'll have the same line on top of the line. And to define these, if you have the same line on top of the line, it crosses at every single point, so these lines are consistent. And since we have the same line or the same intercepts, these two lines are also dependent because they have the same equation or same graph. So the answer would be consistent and dependent. Title of the first section is Solving by Substitution. This question will take two equations and solve for the variables by substitution. First equation, x equals 8 minus 2y. And second equation, 1/2 x minus y equals 18. To solve these equations by substitution, we'll take one equation and substitute it inside the other equation. For example, if we have x equals 8 minus 2y, 8 minus 2y is equal to x, which means we can substitute that into the second equation in place of x. Rewriting the second equation, we'll have 1/2, but instead of x, we'll substitute 8 minus 2y. And then the rest of the equation, minus y equals 18. By substituting for x, we have eliminated or substituted out the x, and now we can just solve for the single variable y. The 1/2 gets distributed to the parentheses. 1/2 of 8 would be 4, and 1/2 of -2 would be -1 or -1y. Minus y equals 18. Combining like terms, -1y minus y would be -2y. And subtracting 4 on both sides, -2y equals 14. Dividing, and we get our first answer, y equals -7. To get our second answer, we know what y is equal to. We want to find out what x is. Looking back at the original question, the first equation was x equals 8 minus 2y. Now we know y is equal to -7. We can plug a -7 in for y and solve for x. X equals 8. -2 times -7 would be +14. And x equals 22. So our two answers, x equals 22 and y equals -7. Title of the last section today is More Substitution Problems. In this section, we'll continue to solve using substitution. First equation is 2x plus y equals 4. Second equation is 3x plus y equals 8. To solve this by substitution, you want to isolate one variable first. So you have either y equals or x equals. To solve by isolating, one step you could subtract 3x on the second equation. That way the 3x's would be cancelled and you'd have y by itself. So y would equal, putting the -3x first, y equals -3x plus 8. Once you have a variable isolated, y equals -3x plus 8, we can take this expression, plug it into the other equation that we have not used, and substitute for that variable. So the first equation, 2x, but instead of y, we'll have -3x plus 8 and equals 4. Make sure when you substitute that you substitute into the other equation that you did not use and never plug it back into the original equation that you used for substitution. Solving this question. 2x minus 3x will be negative x plus 8 equals 4. Subtracting 8. Negative x equals negative 4. And dividing by negative 1, x would equal positive 4. Again, you have two answers for substitution questions. Taking x equals 4, we can plug it back into either question at the beginning, or we can also use the equation that we used to substitute. So in this case, y would equal negative 3x, but we can plug a 4 in for the x. So negative 3 times 4 and plus 8. Simplifying, negative 3 times 4 is negative 12 plus 8. So y equals negative 4. When we have x equals 4 and y equals negative 4, a different way to write that same solution would be to use a point, x comma y, or 4 comma negative 4. What this point represents is if you graph the two equations would cross at 4 comma negative 4. Second question and last question for the section. 3a minus 2b equals negative 1. And second equation, 4a plus b equals 17. Again, solving by substitution, we want to isolate either the a or the b in either equation. The easiest one to isolate would be the b in the second equation by subtracting 4a. So b would equal negative 4a plus 17. Substitution, b equals negative 4a plus 17. We use the second equation to come up with this expression. So we'll plug this one into the equation. We did not use the first equation. Again, always substitute into a different equation rather than the expression that you got from the equation. Solving the first equation is 3a minus 2. Instead of b, we'll substitute negative 4a plus 17 and equals negative 1. Solving, distribute the negative 2. Negative 2 times negative 4, positive 8, and negative 2 times a positive 17, negative 34. 3a plus 8a is 11a minus 34 equals negative 1. Add 33 to both sides. 11a equals negative 1 plus 33, or plus 34, would equal 33. Dividing by 11, and a equals 3. Solving again for b to get our second answer, we can take a equals 3, plug it into either of the original questions, or we can also plug it in to an equation that we used for substitution. In this case, b equals negative 4a, which is negative 4 times 3, plus 17. b equals negative 12 plus 17, or b equals 5. Again, you can leave your answers as a equals 3, b equals 5, or if you want to, you can use a point. Normally it's x comma y. When you have different variables, you'll put the alphabetical order first. So a would go first, which is 3, and b would go second, which is 5. So you'd have 3 comma 5. Title of the first section today is Solving by Elimination. In this question, we'll solve two equations, but we'll solve using elimination, where we'll cancel a variable out. First equation is 2x minus 3y equals 11. Second equation is 2x plus 2y equals 6. To solve using elimination, we can either add or subtract these equations together in order to cancel a variable out. For example, if you look at the x's, they both have the same coefficients, 2x and 2x. If we subtract 2x minus 2x, that would cancel the x variable out. We'll put parentheses around the second equation to remind us that we're subtracting each term in that equation. So 2x minus 2x would cancel. Negative 3y minus 2y would be negative 5y. And 11 minus 6 would be 5. Solving, we can divide by negative 5, and y equals negative 1. To get the second part of the solution, we can take negative 1 for a y value, plug it into either equation, and that'll solve for x. If we take the first equation, 2x minus 3y, but instead of y, we can substitute a negative 1, equals 11. Solving, we have 2x, negative 3 times negative 1 is positive 3, equals 11. Subtracting 3 on both sides, 11 minus 3 would be 8, and dividing by 2, we'll have x equals 4. X equals 4, y equals negative 1, and again you can write that as a point x comma y, which is 4 comma negative 1. Which also means if you graph the two equations on the xy axis, they will cross at 4, negative 1. Next section notes is titled More Elimination Questions. First question and only question for the section is negative 3x plus 7y equals 14. And second equation, 5x plus 2y equals 45. In this question again, we want to add or subtract so we can cancel the x's or y's and solve for the variables. In this question, the coefficients do not match up, so at the beginning we cannot add or subtract. What we need to do is multiply by some numbers so the x's have the same coefficient or the y's have the same coefficient. For example, we can take the first equation and we can multiply by 5, and we can also take the second equation and multiply by 3. This way the first equation, the x's will be 15x, and the second equation will also be 15x. Multiplying the first equation, the 5 will be distributed to each number, each variable, and every term. So 5 times a negative 3x is negative 15x. 5 times 7y, 35y. And 5 times 14 would be 70. Second equation, 3, again times each number and each term, be 15x. 3 times 2y would be 6y, and 3 times 45 would be 135. From here, the x's have the same coefficient, 15. It's okay if they're different signs. What we can do with negative 15 and positive 15 is we can add these two equations together, because negative 15 plus 15 would be 0, or the x's would cancel out. And 35 plus 6y would be 41y, and 70 plus 135 would be 205. Solving from here, we can divide by 41, and y equals 41 goes in evenly to 205, goes in 5 times. So y equals 5. To get our second variable, again, once we have y equals 5, we can use either equation that we started with and plug in y equals 5. You can also use the equations that we multiplied by. If we use the very first equation, negative 3x plus 7y, but we'll substitute a 5 in for the y, and equals 14. Simplifying, we have negative 3x plus 35 equals 14. Subtracting 35 on both sides, negative 3x equals negative 21 divided by negative 3, and x equals 7. So our two answers, x equals 7 and y equals 5. And again, we can write that as a point x comma 5, x comma y, which is 7 comma 5, which again is the point that these two lines would cross on a xy graph. Title of the last section today is No Solution and Infinite Solution. Problems. In this section, we'll continue to use elimination, but instead of answers, we'll either have no solution or infinite solution. First question is 2x plus y equals 5. And second question, 2x plus y equals 6. To solve this question using elimination, if we have 2x and 2x, we can subtract those to cancel out the x's. So 2x minus 2x would cancel. Y minus y would also cancel or be 0. And 5 minus 6 would be negative 1. In this case, the x's and the y's canceled out, and we're left with just numbers. In this case, we have 0 equals negative 1, which is a false statement. If the variables cancel out and you're left with a false statement, the answer would be no solution. The reason this graph or these equations